Good day all. I'm Moses Baloy. I'll be doing the presentation for TPG, which is Transport, Pavement and Geometric Design. The module code is Tpg3700, Assessment 2 of the year 2025. I will then obviously start with the project overview, which is the upgrade of Jimmy Jones Road from a 2-lane gravel to a 4-lane divided highway. Then obviously the focus will be on geometric design, pavement design and drainage design. And then also the design tools that we are going to use is obviously the manual calculations and AutoCAD Civil 3D. The goal is to improve accessibility and regional connection. So in terms of the existing road description, so the road is located in the province, in the northern province, which is Limpopo, and Bembe district. And then currently the road is gravel with obviously poor drainage system. So the road obviously connects Mkomi, Mahonis and Jim Jones to Malamlele and Gyan. So Malamlele and Gyan is the two towns where all the villagers in the area use that road to get to Gyan and Malamlele, where almost everyone, that's where they work. So we'll be obviously upgrading the road to asphalt surfacing and then also with sidewalks. And then obviously in terms of the design data, we then have the design speed of 60 kilometers, and then the lane width will be 3.5, and then the road length we are going to be doing the design, which is the phase 1 of 3.7 kilometers. Then the crossfall of the road will be at 2%, and then the road type will be divided carriageway. Then the design lifespan of the road will be 30 years, and then the road class category B. Then the climate in the area is obviously it's moderate, and then as per appendix 1. I will then move over to geometric design, where obviously I have done manual calculations with reference to the notes from the lecture. Then I've also done used the Civil 3D, where I've inputted my survey data. After inputting my survey data, I then started with the first thing was to group the points to create the surface. After creating the surface, and then created the alignment. After creating the alignment, I then obviously moved on to do the section. And after doing the section, that's when I then created the super elevation. In the process of doing this, I was obviously checking the designs as per TRH 17. And then obviously in terms of our vertical curve, our K value is 83.1, which is greater than the minimum required of 60. And then in terms of pavement structure design, we have used the standard that was used is the TRH4 with the CBR analysis of average of 11.5 and a standard deviation of 1.06. And then obviously the subgrade classified as SG2 because it's a dry region. And then traffic class, it's obviously is 10, pavement class B. I'll then obviously move to pavement alternatives, where option 1 we've got obviously granular base of G2 with G5 of our subgrade layers. And then we'll obviously move on to the cement treated base or C3 or C4. And then we've got hot mix asphalt, and then all alternative include 150mm G7 then rip and recompact G9, the subgrade, which is our in situ, the road bed. And then in terms of design, drainage conceptual design, the key important factor that we need to note, we will have the culverts and obviously the catch pits to drain water out of the road, and obviously also the cap inlet that will be on the edges of the road. And then the design standards that we followed, we obviously use the SANRAL standard and the TRH25 and also the Red Book for stormwater design. And then the purpose of this is to control runoff on the road, just to ensure that when it rains, all the water is channeled out of the road. Also to prevent erosion, as mentioned earlier, that currently the road, it's very difficult to drive on the road when it's raining. And obviously to ensure that we don't have water dams when it's raining, to ensure the safety of the road users. And then the pipe size that will be used will be 900 millimeter reinforced concrete pipe, which will be positioned at Stegville 180, 1180, apologies for that. And then our civil 3D procedure, the first thing, as I've mentioned earlier on, we've imported data, we've created the surface defined element, and from there we have set the design criteria profile. Then we also did create the corridors. Corridors, for purpose of that, was to calculate the volumes. And then we have also extracted cross sections. We have also calculated earthworks, which is the volumes, and also we have exported the drawings. And then obviously under my conclusion, I will then say this was a successful upgrade in terms of the design for falling, and then also the geometric and designs met all the standards, and also this is going to improve access and safety and connectivity for the local commuters. And then also this is going to support local economy, support economic growth, and obviously in the long-term infrastructure resilience. Obviously as I've mentioned, that we have designed this for 30-year lifespan. And then obviously in terms of reference, as I've indicated during my presentation, that I've used the TRH17, TRH4, SANRAL manuals, and then also geometric design manuals from SANRAL, and also the book from the CSIR, which is the road book volume 2 for stormwater design, also 10.2 engineering, and also some of the information that I've got from Huawei online. Thank you for giving me the opportunity to do the presentation. I really appreciate. This will be the end of my presentation. I hope I did well.